A hybrid method approach is introduced here, which is called the Brent method, which is to first apply a speedy open method whenever it's possible, then revert to a reliable bracketing method if necessary. The open method to be used can be the secant method or some other interpolation method, such as inverse quadratic interpolation, which is a method that we do not cover details. All you need to know is that it is similar to the secant method. In the secant method, we use 2 points to get a straight line to intersect with the x-axis. In the inverse quadratic interpolation method, we use more points to get a curve to intersect with the x-axis. The procedure of using more than 2 points to get a curve is called interpolation. Usually, a curve is a better estimation of the original nonlinear function. A built-in MATLAB function f0 adopts the Brent's method in finding roots of a single equation. Here is an example of calling f0 to solve for the root of a simple quadratic x to the power 10 minus 1. The first line of code, calling optimset, is to make sure the detailed procedures are displayed. The second line is to call f0 with the first input as the function itself, the second input as the initial guess, and the third input as options, which is defined by the above line of code using optimset. The previous line. A built-in MATLAB function f0 adopts the Brent's method in finding roots of a single equation. Here is an example of calling f0 to solve for the root of a simple quadratic x to the power 10 minus 1. The first line of code, calling optimset, is to make sure the detailed procedures are displayed later. The second line is to call f0 with the first input as the function itself, the second input as the initial guess, and the third input as options, which is defined by the previous line of code using optimset. Pay attention that after 25 iterations of searching, f0 finds a sign change in the fx column. It then uses interpolation and bisection, shown in the last column, until it gets close enough to the root so that interpolation takes over and rapidly converges to the root. In the end, the root is found as x equals 1. Another built-in function is the function roots, which you are going to use again in a later course, process control and instrumentation. Given polynomial f5x, we can form a vector with the parameters of x to the power 5, 4, all the way down to 0. Then we call the MATLAB built-in function roots to get the solution. If we call the built-in function poly, we can build back the polynomial equation. Pay attention, this function only works for polynomials. The fundamental principles used in engineering problems that requires the analysis of roots. For example, in heat balance, usually the dependent variable is temperature and the independent variables are time and position. The parameters that form the formula include thermal properties of material and system geometry. To summarize today's lecture, we talked about a lot of routing methods, and there are 2 main categories. One is bracketing method, the other is open method. So in bracketing method, we introduced incremental and bisection methods. And in open method, we talked about simple fixed point iteration, Newton-Raphson, and secant method. In the end, we introduced a hybrid method, which use both open method and bracketing, and that's called Brent method. This is the end of lecture 4.